All right, IBSL1, welcome back to another exciting part of 3.3. That's right, we're still doing transformations, but we have not finished them. Last class we mainly talked about transformations with parabolas, with quadratics. Now we're going to talk about just transformations in general, because transformations work the same for any type of function. Before I explain about this everything inside is backwards statement, let's look at this nice little part of a sine curve here. So it's got a nice mountain, and then it touches the x-axis, and then a valley, and then it comes back, and it's 6 units long here. Let's say that this is some version of f of x equals sine of x. The question I want to pose to you guys is, what would y equals sine of, or I guess g of x, sorry. What would g of x equals sine of 2x look like? Now, you guys, a lot of students, when they look at this, they'll go, oh, well, this 2 right here is going to affect something, and it's going to be like some kind of stretch. So if that 2 were outside the function, if it were right here, it would be a vertical stretch of the function, and that's true. Now, inside, a lot of students are like, I bet it's going to be a horizontal stretch. Like, it's going to take that curve and make it longer. It's actually going to go from 0 to 12, which would make sense intuitively, but I want to remind you that the statement I'm making is everything inside works the exact opposite of the way that you think it should. So that 2 inside is actually a horizontal compression. So if I were to draw this graph, let's go dots here, and go a little bit bigger. It would actually start here, and then it would cross halfway in between and then come back. So it would look something like this. So this is what g of x would look like. It's actually a horizontal compression. So not only when you do translations, it works backwards, like an x minus 2 inside actually pushes it 2 to the right instead of to the left. The horizontal compressions and stretches is also backwards. So a number bigger than 1, right here, actually compresses by a factor of 1/2. Like it halves everything instead of doubling everything. I guess we should put that. It's a horizontal compression by a factor of 1/2. All right. Let's do a quick summary of transformations. I realize that you've probably, we've done a lot of these, but we did them all with parabolas. Now we're just going to go into straight function notation, which can look kind of weird to some people, but we're going to list them all out, every single transformation we can have. First one, the reflection in the x-axis is going to be y is equal to negative f of x. Please notice this is a negative outside the function, and it turns it upside down, so it flips over the x-axis. So it's like a vertical flip. Now, a reflection in the y-axis is like a left-right flip and would be a negative inside the function. So that's a horizontal flip. Vertical dilations are when you take some function and multiply it by a scale factor of a. When a is bigger than 1, so like 2, 3, 4, 5, or like -2, -3, -4, -5, the absolute value of that will produce a vertical stretch. When it's in between 0 and 1, like 1/2 or -1/3, that is a vertical compression. It gets squished from the top and the bottom. Horizontal dilations are inside the function. So you're still going to multiply by some scale factor, but let's call it q. So something gets multiplied inside the function. Now, this is the exact backwards relationship of the vertical dilations. So vertical dilations, when a is bigger than 1, that's a stretch. And when it's a fraction in between 0 and 1, that's a compression. Down here, it's the exact opposite. That a stretch happens when it's a fraction between 0 and 1, and a compression happens when it's bigger than 1. So, this is backwards of how we want it to be. Backwards of how you think it should work. Just a reminder, once again, everything inside works the exact opposite of the way you want it to. Vertical translations. Now, a translation doesn't affect the shape. There's no squish or stretch. It just moves it like left, right, up, or down. So an up or down translation would be the function plus some sort of k on the outside. When k is positive, it goes up. And when k is negative, it goes down. That one works the way you think it should. So outside works the way you think it should. Inside is the exact opposite of the way you think it should. So horizontal is going to be some sort of h being subtracted. And it moves to the right when h is less than 0, and it moves to the left when h is greater than 0. So negatives push it to the right, positives push it to the left. Yeah. I guess actually if I'm saying that, I should put a plus here, not a minus. Because then if h is negative, it'll be like x minus a number. So once again, flippy floppy. Everything's upside down. Okay, the last part of this lesson, we're just going to take this function, f of x, and then we're going to transform it like 3 different times. The way I attack these problems is I think about them in a much of a coordinate style way of thinking. That this coordinate here is 4, 2. This one is 6, 0. This one is 0, 2. And this one is -2, 3. So there's 4 coordinates on here. Now, you guys, this part right here, if we're going to graph this, it's taking this function, this weird little staircase function or slide or whatever you want to call it, and doing this transformation. So this transformation is going to be a vertical stretch by a factor of 2. So the only thing it affects is the y values. The x values are going to stay in place, but the y values are going to get pulled away from the x-axis and doubled. So, for instance, this -2, 3 is going to become -2, 6. So here we have to go to -2, -1, -2. So that one is going to be all the way up here because the x or the y value got doubled. Then 0, 2 is going to get doubled as well, so it'll be 0, 4. Then 4, 2 will become 4, 4. I guess I should label these. And the last one, 6, 0. Well, if you double the 0, you just get 0 again, so that one actually doesn't move. Then you play connect the dots. Whoops. Get out of here. How did I do that? There we go. There we go. That's what it would look like if we get twice as tall. Now, if we use the same starting function again, this negative inside the function is going to be a horizontal reflection. So, this little brontosaurus shape, whatever you want to call it, is going to get flipped around the y-axis. What that does to the coordinates is it takes all the x values and turns them opposite. So this 6, 0 would become -6, 0. 4, 2 will become negative 4, 2. So negative 4, 2 here. This point, if you flip it around the y-axis, actually does not change at all because it just stays right in that spinny spot. And then negative 2, 3 will spin around to this side and become positive 2, 3. So here's 1, here's 2. And then if I play connect the dots, that's what it would look like. Last one, ooh, double trouble. We got 2 transformations, you guys. Here, this is a horizontal translation to the right one. Remember, it's the opposite. So this moves it to right 1. And then this moves it, it's a vertical translation. It's going to go down 3. So each, of these coordinates, if I take negative 2, 3, I have to move it to the right 1 and down 3. If I move it to the right 1, it becomes negative 3, 3. But then if I move it down 3, it becomes negative 3, 0. Did I do that right? Hold on. Negative 2, 3. So if you move it to the right 1, oh, that would be negative 1 and then down. So that would be negative 1, 0. Sorry, I did my horizontal translation wrong the first time. So yeah, to the right 1 would be negative 1, and then down 3 would be 0. So that point moves to right here. Zero, 2. To the right 1 would be 1, 2. Down 3, well, it'd be 2 minus 3 is negative 1. So that would be 1, negative 1. Should be right here. Next point up, 4, 2. Let's see, to the right 1 makes it 5, down 3 makes it negative 1. So that would be 5, negative 1. Last one is 6, 0. To the right 1 would make it 7, and then down 3 makes it 7, negative 3. So if I connect the dots, it would look something like that. So still the same shape. There's been no stretch or anything. It just got pushed to the right 1 and down 3. I imagine a test style question might be like, take this and then sketch y is equal to negative 1/2 f of x minus 3 plus 5. Something like that. Triple trouble. All right, guys, that's all I got for you today. Next class, we'll start to talk about 3